Yo, new video. We're doing Advent of code today. I didn't record the first 2 days, but it is day 3, and let's just get right into it. So this is day 3, rucksack reorganization. So I'm gonna try to read this real quick, and then I'm gonna get into the solution. And I am using Rust, by the way. So let's see. So one elf has the important job when all the rucksacks were supplied. Elf didn't quite follow the packing instructions. Each rucksack has 2 compartments. All items of a given type are meant to go into exactly one of the 2. Elf did the packing, failed to follow this rule for exactly 1 item per rucksack. The elves made a list of all of the items currently in each, which are input. Find the errors, and every item is identified by a single letter and operate lowercase different. List of items for each rucksack, same as a character, all in one line. Each rucksack has same numbers in each compartment. So first half is the first compartment, second half, okay. And as an example, we have these. Of course, first half, second half. Oh, and then of course the error is that there's one item type that's in both compartments, I guess. And to prioritize the rearrangement, item type can be converted to priority. A to Z, 1 to 26, capital A to Z, 27, okay. And in the above example, so we find the one that is in both, and then we just find the priority, and then we get the sum. Okay. Oops. So let me just try to put in the input. Oh, it's not day 2 anymore. Okay. And day 3. Okay. So let's get our input real quick. Let's use an include string. Then we're going to need the input later. So we can let's just print the output, input, to make sure that run bin day 3. Oh my gosh, I keep forgetting. It's day 3. Alright. Okay. So I guess the first thing to do is have an answer, which is the priority sum. Let me just have that 0. And let's see if we can go through each rucksack in the inputs. Let's just get the lines. Let's make we can make a. Ooh, do we need hash set? We could actually use what's it called? Bitwise operations if we want. Guys, let's do that. Since this only goes to, what's this, 52. So let's do items equals 0. Let's make this an I value 64. Say for rucksack dot, what's that called? So we have a string. We get all the characters, and then we have to, what's it called? We have to skip the end. So I forget how to do that. I guess take. So we only take the first half, which is rucksack. We get each compartment, and let's say items equals item. All right, of course. Item value equals. Let's see. Let's make another function. Let's just get item value, and this takes in a char. And it's gonna use 64. So if the char is greater or equal to 8, and it's also equal to 7. Let's say I borrow this. We can return just the value minus 8. Can't subtract. Oh, I forget. Or can you? Anyways, I'll deal with this later. Plus 26. That's in char. In Rust, chars are kind of weird. I need this to be like ASCII. Okay, but assuming that works, we can get item value of the item and take 1 and we shift it for how much and borrow. That's how I need to borrow. So let's, for now, let's just return something that works. And then we'll deal with that later. Now for item in rucksack, chars, skip. Now this is the second half. We can say if items, let's see, how do we check if a bit is already switched on? We have an and when it's shifted over by this right here. If this does not equal to 0, this is the thing. So let's get item And let's just add this to the priority. Plus equals item value. And I think that should be good. And we print out priority sum. And I guess we need to have this figured out. So we can't subtract char from char. Let me see. Is there a way to map? I see. Two-digit escape. I'll be right. Alright, so I think found the way you just cast this as a U32. I think that's, I guess, how you just make this ASCII. So let's see. We do this and we're gonna add 26 as well. And it should work. Alright, so let's run day 3 and the day 3. And the priority sum is 0 somehow. So let's just here print out items and have some values. So really the only time we're adding is here. And if items and shift item values times we don't even loop. It's a bit of a problem. So here we can take here. Do we even loop? Yeah, we do. Bunch of here's, but no here too. The first n elements. Oh, of course, my bad. Compartment length should be half of the thing. So we got 151, and it's supposed to be 157. I think I know. Yeah, I think I know. So we just add 1 each time because this is from 1 to 26. What I was doing before was 1 to 25. So it should work. Okay. Let's try the actual thing. Of course I don't have anything in here yet. If we run, we get some output, we submit, and it's the right answer. Let's go. Okay. Now part 2. Let's see. Let's call this part 1. Now let's do part 2, right? After finishing identifying the misplaced items, come with another issue. Elves are divided into groups of 3. Each elf carries a badge. And within each group of 3, badge is the only item type. Whoa, okay. Coming by all 3 elves. That is, if whose badge is B, all 3 elves will have item B somewhere. At most 2 of the elves will be carrying the other. Okay. The only problem is that someone forgot to put this year's updated authenticity sticker on their badges. So maybe pulled out the badge size so the rucksack attached. Nobody wrote down which item corresponds to each badge. Finding the one that's common between all 3 elves. Okay. So every set of 3 lines in your corresponds to a single group, but each group can have different badge item type. So the first group's rucksacks are the lines, the second are the set. Okay. And the first group, the only item that appears in all 3 is lowercase r. So must be the badge. Second, it's whatever. And then we still, I guess, add up the sum still. Okay. So I do have to go about this a bit differently. Let me think. So this is the first, so there's an R here. It's an R. Let's see. First group, the only item that appears in all 3. So do we care about the compartments or not? I guess we don't care about the compartments. Okay. Let's say instead of let's have an index, and this is index. This is in group. While group is less than what's it called? If I want to do it like this, let's have lines equals input dot lines, okay? And let's just say lines dot, let's just do all true. Let's see. And we want to go 3 at a time, so let's rucksack 1 equals lines dot next. Oh, hello. So 1, 2, and 3. Make it like this. And I guess we can unwrap. So we'll lines dot. Do we even need to do this? You know, I don't really care. Let's just do a loop. It'll just panic the program. Whatever. Don't care. So let's have an what's it called? Items equals 0 to 64 again. Items. Ooh, that is interesting. Okay. Thinking, is this still the best solution? Cause I can just have this and for I guess I split this off in another function. Don't have to. I'll just do it for now. So for item in dot charts, we do what we did before, so which is one which gets item value of item. Do this. Item 1 replace 3. Item 1 replace 3. Let item equals the items 1 and items 2 and items 3. And this should be the item that is in all of them. And priority sum plus equals on item. The final item right now, we're looking for the position of the bits, I guess. The bits. Should I guess? How do we find the bit? Give me a sec. Alright, I think I found what to do, which is using log. This is unsafe. What about log 2? Log 2. Alright. Now we're just gonna get the log base 2 of final item and as U64. Why not U64? This is I32. Does it work? Oh, 32. Right, and let's just add it. Just so I make sure this is good. Is there anything wrong still? Okay, it's looping forever. So I'm gonna just do this for now. I don't need the loop. Let's just try this out. I know it's in a panic, but let's just try this. And we do panic in a priority sum. Something crazy. Is this day3 sample? Really? So it is adding a lot. And why is that? Why is that? So we're looping. Should only be 70. It's adding more than the number of lines that exist. I don't think that is intentional. Let's just print out the values of the rucksacks and let's And let's put like a little separator. It's a bunch of random stuff. Oh, I used it. That's in the wrong function. Nah. Okay. So if we run the example, we get 70, and that's part of 1. And if we run this, it's like 2000. It seems kind of low, but it is the right answer. All right. I really don't like how this program just crashes when it reaches that. I mean, I guess that is Advent code day 3 finish. I just want to make sure that this is possible to just check if there is a next. I guess what I could do as I have a match here and it just breaks when it unwraps. Anyways, I guess that's it for this video. Let's advent a code day 3 using bitwise operators and storing items as a U64. That's it. Okay.